Today we're going to continue counting for slope, which is the rise over the run of a line or the vertical change divided by the horizontal change. So in this first problem, they want us to get from A to B, and they're asking how we move. They want us to move up and to the right. So if I start at A, and I know that I'm moving up to get to B, I'm moving up 1, 2, and I'm moving right 1, 2, 3. So we moved up 2, we moved right 3 units to the right, so our slope must be 2/3. So if we look at how we're going to get from B to C, we want to count how many units up and how many units to the right. So we're going up 1, 2, 3, 4, and we're running to the right 1, 2, 3, 4, 5, 6. So 4 units up and 6 units to the right makes a slope of 4/6, 4 over 6. What relationship do we see between these two slopes? Well, hopefully we can see that 4/6 is simplified as a fraction to 2/3. So both of these have a slope of 2/3. They have to, because this line has one slope. It's moving at a constant rate of change. And that change is that we can go up 2 and over 3, up 2 and over 3, and we'll be back on the line. Up 2 units and over 3 units will put us back on the line. Let's take a look at another problem. This one has us going from L to M. To get from L to M, I want to move up 1, 2, 3, 4, 5, 6 units, and we're moving right 2 units. So if we move 6 units up and 2 units to the right, the slope is 6/2. Hopefully we can see that 6/2 is simplified to 3/1, which is also the same as 3. So let's see what happens if we're going from J to K. From J to K, we move up 1, 2, 3 units, and we're moving 1 unit to the right. Well, 3 over 1, a slope of 3 over 1, simplifies to 3. So the relationship between these two slopes is that it is 3. Now hopefully this makes sense because this line is a constant line. It's a constant path, a constant rate of change. And in every case, we're moving up 3 and over 1 to get back on the line. Up 3 over 1 and we're back on the line. You guessed it, up 3 and over 1, we're back on the line. Which means every multiple of 3 over 1 is going to be an equivalent fraction that we'll be able to find on this line. Let's try one more. To get from R to S, you might notice something's changed. To get from R to S, we have to go down in order to run right. And it's asking us to move units to the right. And we can see here that we're also moving down. So if I start at R and I'm moving down to get to S, it's down 1, 2, 3, 4 units. And then we're moving 1, 2 to the right. So 4 units down and 2 to the right. Well, if I want to write that as slope, 4 units down is a -4, and 2 units to the right is 2. Well, -4 divided by 2 is going to equal -2. Let's see what happens when we go to get from Q to T. If I start at Q and I want to get to T, I have to go down in order to run to the right. So I'm moving down 1, 2, 3, 4, 5, 6, 7, 8, and running to the right 1, 2, 3, 4. Well, 8 units down and 4 units to the right gives me a -8 over 4. That is the slope of the line, but when we simplify it, we're going to get -2. So the relationship between these two slopes is -2. Now, let's put this to practice. It asks us to determine the slope for each line on this page. Where necessary, draw the slope triangle, then write the slope as a fraction. When we're moving down, the numerator has to be negative, and of course, we'll simplify the fractions whenever possible. So if we look at this line here, hopefully we can see that it's a positive slope, and if I'm going from this point to this point, we're going up 2, and we're going right 3. 2 units up and 3 units right is a slope of 2/3. Let's try the next one. I can see that I do have a positive slope. It's going uphill. And if we're going from this point to this point, we're counting up 1, 2, 3, 4, 5, 6, and 2 units to the right. Well, 6 units up and 2 units to the right gives us a slope of 6/2, which is simplified to 3/1, which is the same as 3. The slope of this line, up 3/1, up 3/1, up 3/1. This last one with a slope triangle here looks a little different because we can see that it's a downward slope. It's going downhill. So I can see that I'm going down 1, 2, 3, and we're going over to the right 1, 2, 3, 4, 5. Well, going to the right is positive, but going down is a negative. So we have -3/5. So our slope is -3/5. And that's as far as it can go, right? There's no more simplification. For these next few problems, we'll see that there is no slope triangle on there, but they do give us some points on some of the lines. So for example, this one, we can see a point here and here. So if I want to run to the right, I can see that I'm moving up 1, 2, 3, 4, and to the right 1, 2, 3. So our slope is up 4, right 3. Our slope must be 4/3. The one below it does not have 2 points, so you're going to have to choose 2 points. And I'm going to choose this point here, this point here, and looks like it crosses here. This one's not drawn perfectly, but if I choose those 2 points, I'll see that I can go up 2 and over 2. Well, up 2 and over 2 gives us a slope of 2/2, which is the same as 1. So we know that we can go up 1, over 1, and be back on the line. Up 1, over 1, and be back on the line. Go ahead and finish these last few problems, and then you can get started on the next practice sheet.